Welcome to GMST Davanagere. I'm Anil Kumar TRV, Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to study the experiment number 2, that is the static characteristics of IGBT. Experiment number 2, static characteristics of IGBT, that is insulated gate bipolar transistor. Contents: aim of the experiment, theory, apparatus required, circuit diagram, procedure, calculations, results and graph. Aim: to plot the transfer and output characteristics of an IGBT and determine the transconductance and output resistance. So when you talk about the theory, IGBT is a newly developed in the era of power MOSFETs technology. This device combines the advantage of both a MOSFET and IGBT. So an IGBT has a high input impedance like a MOSFET and low on-state power loss in the BJT. The parameter and their symbols are similar to that of the MOSFET, except that the subscript for source and drain are changed to emitter to collector respectively. The current rating of the IGBT is up to 400 amperes, and the switching frequencies can up to the 20 kilohertz. So this is actually circuit diagrams. We have an IGBT where we have the terminals called gate, collector and emitter. So gate to emitter voltage is we are providing 0 to 15 volts, and collector to emitter voltage we are providing 0 to 50 volts. So we have the voltmeter across the collector to emitter, and we have the ammeter to see what is the collector current, and also we have the voltmeter across the gate to emitter voltage to measure the gate to emitter voltage. So these are apparatus required: IGBT, resistor, ammeter, voltmeter, multimeter, RPS and connecting wires. So procedure for transconductance: make the connections as per the given circuit diagram. Initially keep V1 and V2 at 0 voltage, switch on the regulated power supply by varying V1 set to VDS to some constant voltage, say around 5 volts, vary V2 in steps of 0.5 volts, and at each step the note on the readings of values of VGS and AD. Reduce V1 and V2 0 by varying V1 and V1 set VDS to some other value, say 10 volts. Repeat the step number 4 and then plot the graph, that is VDS versus ID. For drain characteristics, make the connections for this given circuit diagram. Initially keep V1 and V2 0 volts by varying V2 set VGS to some constant voltage by gradually increasing V1, note down the corresponding values of VDS and ID. Then set VGS to some other value more than threshold voltage and repeat the step 4. Plot the graph of VDS versus ID for different value of VGS. So these are the characteristics for VCS set for 10 volts and VC2 set for 15 volts. So voltage to gate emitter, voltage gate emitter voltage is 0.0 and collector current is 0. 5.05 it is 0.1, for 8 it is 1.4, for 9.4 it is 1.4. This is for the another values for VC to 15 volts. These are the readings we have taken. For drain characteristics, for VG1 is 5.05 volts, for VC collector emitter voltage is 0.2 volts. And ID, the drain current is 0.5, for 0.6 it is 1.0, 1.0 it is 2, for 24 it is 5.8 and 24 it is 5.8. And calculation, when you go to the point of calculation, we need to find out the transconductance at the constant VDS, that is delta ID by delta VGS. For output resistance R0, that is at constant VGS, delta VDS divided by delta ID. So this is actually graph, that is a collector to emitter voltage in the x-axis and collector current in the milliamperes in the y-axis. This is actually the threshold voltage VGE. For the characteristics, for output characteristics, we are keeping the VG1 and VG2 for the different value of the voltages, and we are getting the plot like this. So result: steady state output and transfer characteristics of IGBT is plotted and observed. So let us see how the IGBT will work in the real time. So we shall do the experiments on IGBT to find out the characteristics of IGBT. Hello everyone. I am Anil Kumar TRV, Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to study the VI characteristics of a IGBT. So let us see what are the apparatus are required. So this is a IGBT characteristic study unit. So we have to make the connection as per the given circuit diagrams. After making the connections, we need to set the, so that is the collector to emitter voltage to the minimum of 10 voltage. So I set it for the 10 volts. This is 10 volts now. Now we have to vary the gate to emitter voltage. So that is gate to emitter voltage. We need to check in the VGE here on the display. So I'll set it for the around 2.7, 2.8, 2.93. Let us set what value of the collector current will rise. So 3.6 it is 0, 4.2 it is 0, 5 it is almost 0.1. So it is around 5.2 is the threshold voltage. So that is the threshold voltage for the IGBT. So I set it for the VC as 10 volts. For VG it is 1.0, it is 0 volt. For 2 it is 0, 3 it is 0, 4.2 it is 0. For 5.09 it was 0.1. that is a collector current. At this value, the device was IGBT was going to turn on. This is the minimum threshold voltage. So 5.35 it is 1.4, 5.6, 6.0 it is 1.4, 7 it is 0, 8 it is 1.4, 9.4 it is 1.4. It is going to become saturation. This is the input characteristics. Now we need to find out the output characteristics. So for that we already know what is a VG. We have set it for the 5.4 above the threshold voltage, that is 5.49. Now we need to vary the VCE voltage. Then we see what is a collector current. So it is 0.7, it is 2.5, 0.8 it is 3.7, 2.6 3.8, 4.3 it is 3.8, 7.9 it is 3.9, 10.5 it is 4.0, for 11 it is 4.1. Now it is becoming saturations. So we need to find out the VC and IC current. So for VC 0.8 it is 0.5 volt, for 0.6 volt it is 1.0, 0.7 it is 2, 0.73, 10, 4, 23, 5, 23, 5.8, 24, 5.8, 24, 5. It is going to become saturation at this point. This is the output characteristics. So we need to plot the against the VC and IC. Thank you.